All right, we want to go to this last section now. A says this, what is a uniform, part A of this section, what is a uniform probability model? We want to take all of our knowledge that we've discovered about probability. We've talked about outcomes. We've talked about sample spaces. We've talked about experiments and, importantly, events. We also looked at our Venn diagrams. We talked about complements. We talked about mutually exclusive. We talked about also this last one about relative frequency, about the percentages. We talked about the law of large numbers. Now we want to create probability models. Okay, so this is going to be our last topic of the year. A probability model is this. It's going to be a table or something similar showing the sample space of outcomes, events, and probabilities of those outcomes and events. Okay, we call this a probability distribution. Distribution means how is that probability distributed among all of the different possible outcomes of these events. Okay, let's give a real simple example of this. If we have a probability model of flipping a coin, what we're saying is, okay, the outcomes are heads or tails. The event is the probability of rolling a heads, which is 1/2, and the probability of flipping a tails, which is also 1/2. This is going to be a probability model of flipping a coin. Very simple, right? And we're actually going to call this one a uniform probability model, which is the point of this lesson, because each outcome, right, the probability of each outcome is the same. Whether it's heads or tails, it's 50%, 0.5, or 1/2 for every single one. Whenever the outcome probabilities are all the same, we call that uniform. Uniform is a word that means everything's the same. When people wear a uniform to work, everybody's dressed the same. So when we have a uniform model, all the probabilities are going to be the same. All right, Ben now randomly selects a counter from the group of counters below. He then, I think it's going to be, he's going to select. He reads the color of the selected counter. All right, so define the sample space. Well, the sample space in this one, it could either be what? The sample space could be yellow or red or blue or green or black. Those are going to be the 5 options. That's the sample space. What is the probability of selecting a counter with a particular color? Well, since there are 5 of them, they're all equally probable. So these each would be 1/5, right? They're all 1/5. It all has to add up to 1 of each color. So with that, we can now make a model, a proper model for the particular color. So I would write the colors here, yellow. Oh, come on, we can do a little better than that. Let's go ahead and do yellow. And then we have red. And then we're going to have blue. And then we're going to have green. And then we're going to have black. Okay, now I'm going to write, I'll just use purple for these. I'm going to write the probability. I'll put these in decimals just to do something different. 0.2, 0.2, 0.2, 0.2, 0.2. Okay, is that going to be uniform? Yes, because they're all the same. All right, so it says then use a bar graph to show the probability distribution. Remember a bar graph, these are going to be spread out. So a bar graph in this case, look, let's just make a bar graph. We'll make our line here. They're all 20%, so we could do 5%, 10%, 15%, 20%, 25%, 30%. And I could put my colors down here. So I could put yellow. Let me go ahead and put a bar down here. I could put yellow, red, blue, green, and black. Okay, and I would label this also colors chosen. And so I'm going to go ahead and make the model there. Go ahead and use those colors again. Yellow is going to be 20%. Okay, that's going to be yellow, 20%. Red, on a bar model here as well, I want to try to put, I'm going to put 2 spaces in between. You want to be consistent. They're all 3 across. I want to make each of them 3 wide with a space of 2 between them. As long as you're consistent, it doesn't really matter what you do there. 1, 2, 3. Okay, and then green, space of 2, and 3. Okay, I put the green there, and then the black. Make the black this last one here, 2 with 3. All right, perfect. Okay, that would be a bar graph. Remember, bar has to have a space in between, and it has to have the same space. In this case, it's uniform, so they're all going to be at that 20% mark. And I'm also going to make them all the same width. They're all going to be, in my case, 3 squares wide. Okay, that's going to be good to have a proper bar model, just as a reminder from last year. And there's an example in case you wanted to see something else. This is basically the same thing that we just did. Probability, the outcome. All right, if the sample space of a uniform probability model consists of n possible outcomes, like we had 5 possible outcomes in our last one, then the probability of each column is 1 out of n, or in our case, 1 out of 5, which is that 20%. Okay. Jane, Mark, Jason, Ruth, Albert, Kenny, and Chloe are students. A teacher randomly chooses one of them to answer a question. Explain why a uniform probability model describes this situation. Well, because I have 1, 2, 3, 4, 5, 6, 7 students. 7, I have 7 students who are equally likely to be chosen. So that means it's uniform. What is the probability that Ruth is chosen to answer the question? Well, the probability would be 1 out of 7. The probability of Ruth is equal to 1 out of 7. If A is the event that a girl is selected, find the probability of A. Well, the probability of A, if a girl, that would be 1 Jane, Ruth, and Chloe. So the probability would be 3 out of 7. The probability of that event A, a girl is selected, is 3 out of 7. All right, let me know if you have any questions. This one's pretty straightforward.